Hello students, today we're going to learn about some of the five main types of chemical reactions. Okay, but before we do that, let's go over quickly over the things that you know already. Okay, first you know that a chemical reaction occurs when two or more substances react, okay, and they yield or produce a product. They have to follow the law of conservation of mass, which means we're going to balance all the equations, the chemical equations, and we have to know for a fact that a chemical change is happening, such as a color change, evolution of gas, formation of a solid, things like that. Okay, we have to know that there's a chemical change happening. The first type of chemical reaction that we're going to go over is a synthesis reaction. Okay, that reaction can also be called a combination, okay? But synthesis essentially means you're just making something new, okay? So two substances combine to form a new substance, and you can think of it as like marriage, okay? You have one unit and another unit, okay, or two different people coming together to make a single unit, okay, or a couple. For example, here we have magnesium and oxygen coming together to make magnesium oxide. Okay, here we have calcium oxide and water coming together to make calcium hydroxide. Okay, so again, it can be called synthesis or combination reaction. Okay. Decomposition. Okay, as you can think, decomposition is when something breaks down into two or more substances. Okay, so if we follow through with our dating analogy, that's going to be like a breakup. So we have a couple breaking up, okay, into two different substances. So hydrogen peroxide, okay, is breaking up into water and oxygen. All right. Another example is sodium nitrite breaking up into sodium and nitrogen gas. And this is actually the reaction that happens in airbags in your car. Okay. The gas that fills up the airbag is nitrogen gas. Decomposition reactions need heat, okay, or electricity in order to happen most of the time. Okay, water can be broken down into hydrogen gas and oxygen when electricity is added. Okay, and we call that process electrolysis. A single replacement reaction, as if you think about the name, it's one being replaced. Okay, so one substance is replaced by another more active substance. So we're going to think rejection in our dating analogy. So we have a single person and a couple, and A here is going to kick B out of the picture. Okay, and B is going to be by itself in the end. Okay, so here we have, for example, uh, excuse me, lithium, okay, and water. And you can think of water as HOH, okay? So we're going to have B and then Y. Now here we have lithium oxide, which is our AY, and then we have hydrogen gas by itself, which will become our B. Okay, so A plus BY, B gets kicked out and A replaces it. Double replacement reactions you can think is to replace, okay? Some examples here is when involves an exchange of two ions or of ions in two different compounds. Okay, some people like to call this a wife swap. Okay, if you think of two couples swapping wives, you could also call it the husband swap, whatever you'd like to call it. But it's AB, one couple, plus XY, another couple. Okay, so I'm gonna just so you can see circle, circle, square, square. And then they're going to flip here. We're going to have A, Y, and then X, B. Okay? So here, for example, potassium is A, iodide is B, lead is X, nitrate is Y. We're going to have lead, which is going to be our X, and then iodide is our B, potassium is our A, and then nitrate is our Y. So the easiest way to, when you're trying to solve these problems, is just actually go ahead and write the A, B, X, Y, and things like that. It'll make it a lot easier for you. Okay. Usually the products, you're going to get a precipitate, which is a solid. Okay, an insoluble gas, or water. You're usually going to have one of these three things, okay, in the product for double replacement reactions. The last one is called combustion. Okay, not to be confused with combination. This is combustion, and will always have something to do with fire. Okay, here's my cabin fire. All right. This reaction will always have a hydrocarbon, okay? That's a compound with hydrogen and carbon reacting with oxygen, because remember, you always need oxygen to have fire. And it's going to make water and carbon dioxide, okay? It does not have an ABXY pattern. This is just usually what it looks like, okay? Combustion reactions, that's what they look like. Okay, easy way to identify is looking for CO2 in the product and H2O in the product. Okay, and then of course it always has to have oxygen in order to have fire. All right, so those are the main types of reactions. Okay, let's do a quick overview. Okay, so we have synthesis. Okay, two becoming one. We have decomposition, one becoming two. We have combustion, which we're going to have a hydrocarbon and oxygen, making carbon dioxide, water. There's also usually heat and light, and sometimes an oxide of a compound. Okay. Single replacement is when here Y in this case is going to replace B. Okay, and B is going to get kicked out. And of course, in this case is where A is going to go with Y for double replacement, and B is going to go with X. All right, and that's it.